Very good. Welcome on this Tuesday afternoon in Europe to a new edition of our webinar on the future of open data portals. It is my greatest pleasure to introduce to you today's speaker, Natasha Noy. She's not just a friend of mine, but also a research scientist at GoogleAI. Where she works on anything related to data, in particular structured data on the web. And she thinks with her team about ways to make it more accessible and more useful for a range of audiences. This resonates very well with the aims we are following in the European Data Portal as well, in public sector data. Her team has developed a tool which some of you, including her teenage daughter, might have already used successfully, Google Dataset Search, which helps users find datasets that are available online. Before joining Google, Natasha was at the Stanford Center for Biomedical Informatics Research, and she worked in the Protégé group, which if you work in anything related to knowledge graphs, knowledge engineering, taxonomies, information sciences, is very well known for developing a platform for editing and managing ontologies, which is used by hundreds of thousands of people all over the world in many disciplines. Natasha is going to talk today about Google Dataset Search and how to build an open ecosystem for dataset discovery. Thank you, Natasha.
Thank you, Elena. Thank you for this very kind introduction, and thank you for inviting me. I'm excited to talk to all of you about the work that we're doing on dataset search, but use it also as a prism to think a little bit about kind of what an open ecosystem for dataset discovery will be. Sorry, okay. So, and the emphasis here will be on a couple, the emphasis in the next 40 minutes or so, and I'll leave plenty of time for questions and discussion, will be on a couple of words in the sentence. The first one is open, and how do we kind of think in our work on dataset search and in our work on building the engine of doing this in this ecosystem where it's sort of open to everybody. And then specifically, we will focus on discovery, and I will come back to that point quite a few times today because discovery is really the niche that we're trying to solve. After all, you know, that's kind of the mission of the company in general, to organize the world's information and make it accessible and universally accessible and useful. And so that's sort of the niche that our team is trying to fit in the context of data science. So, and why are we trying to do something like that? So the first question, you know, if you ask yourself, where do you usually look for data? And for many people probably on this call, well, if I need European data, in particular government data, I probably go to the European data portal. And this is great, and this is a great answer. For most people, the answer is, of course, on the web, because we don't actually know what those specific portals for specific types of information are. And those portals do need to exist. They always will be the best for representing a specific type of information. But unless you're part of a specific research community or specific data community or just a specific community, you may not know what the portal is and where should you go to find the data. And that's sort of the way we're thinking about this as about dataset search in particular, is a way to tell people where to go. Right? Where is the data of a particular type? And I don't need to tell you, you know this, everybody on this call probably knows this as well as I do, that there's thousands of data repositories across the web that cover millions of data sets. And so, again, if I'm in the medical community, I probably know what are the best repositories for life science data. Or if I'm interested in, you know, marine data or ocean data, I know where to go. But if I want to correlate that maybe with some population data, that I may not necessarily know which of the repositories to go to. And that is the problem that we're trying to tackle. Sort of think of this, many of you on this call, I'm pretty sure all of you are familiar with Google Scholar. So it's kind of the same thing, right? We're thinking of this as a Google Scholar, but for data sets. Because again, we know there's Elsevier, there's Springer, there's ACM Digital Library. There are lots of different repositories for papers where papers are published, but we need a uniform way to access that. So hence Dataset Search, the tool that we have built. Again, basically the easiest way to think about it is a Google Scholar for data, where you search for something, you get results, then we the results. I used a particular portal here as one of the results, but the goal is, we show you the metadata. I mean, I used European data portal, of course, and then we basically tell the user go to the European data portal. So there are a couple of things that I want to point out here is that we focus on metadata, right? So we don't try to search over the data. Our goal is to use metadata as a way to understand where the data is. And I'll come back to that point quite a bit because that's where standards for metadata come in. That's where publishing metadata comes in. And understanding metadata and trying to interpret it as much as we can. And so that's kind of the key goal that we see for us. And when we think about metadata and when we think about the web and the data sets as they're present on the web in any kind of repository, any kind of portal, compared to everything else on the web, right? So for any page that what we need to decide whether to include it in a data set search, any data set search, there are two questions that we really need to answer, and that's and on the technical level. And one, which is probably the most difficult in some sense, is this page about a data set, right? So it's easier a little bit with things like data portals because, there's some not small, but a limited number of them. So we can say, okay, everything there is a data set. Of course, if we're trying to go on the web scale and we're trying to actually include one of the pages describing data sets somewhere, not necessarily in the large repository. So just actually answering this binary question, kind of a yes or no question, does this page represent a data set, is the first thing that we need to be able to answer and kind of create our slice of the web index, essentially, that only includes pages with data sets. And then once we know that a page contains a data set, what we would like to know from that page are different salient properties of the data set. What its title, what its description, what are the download formats, where do you go to download it, if it's, for example, data set that covers certain geography, what is its spatial coverage, what is temporal coverage, what is the licensing information. I'll come back to that in a few minutes. So, but these are if you think about kind of the technical part of our work, these are the two questions that we're trying to answer. And so the way we try to answer it for the most part is using open standards. Actually, the way we're trying to answer it using open standards, period. But for the most part, we rely on schema.org. And I assume that most of you have at least heard about it or know about it. But basically, it's a structured data markup. It was it's a vocabulary that was founded by consortium of search engines. In the beginning, it was Google, Bing, Yahoo, and Yandex. It's very widely used on the web. It's today on about a third of web pages, if not more. The nice thing about schema.org is there's several ways to embed it in HTML. So the pages remain the way they are. The pages basically look exactly as web designers want the pages to look for their users, and then this information is just embedded in that HTML so that any search engine or anybody else really processing that page can understand, can get these salient properties. Its adoption and its use is driven by real use cases in usually search engines. And the nice thing is it's an open standard. It's not part of any formal open standard, any formal standards body, but it is open. There's a steering committee, and no one company owns it. It's not proprietary. There are lots of open source tools. So another advantage why our team zeroed in on it is because, as is many other search engines at Google, it's actually used in a lot of products. So for example, when you search for recipes, and I don't know if it was the craze in Europe, but it was definitely in the US at the beginning of the pandemic when everybody was at home, everybody was baking bread. It was just a thing. And so if you search for bread recipes on Google or probably on Bing, you get a set of cards like that. As it happens, if you actually open that page and look at the HTML for every one of those pages, this information, the stars, the title of the recipe, how long it takes, what are the ingredients, all of that comes from schema.org markup. Similarly, if you search for jobs, what you get is a set of cards where all of that structured data comes from schema.org markup. So essentially, not only it's very widely used on the web, there are a lot of tools that know how to process it. But also, since 2011, in almost 10 years, kind of have acquired a lot of knowledge of how to make it easier for webmasters to embed it. Lots of content management systems actually allow you to basically just enable it. And so that's why we said, for data sets, when we started, there was schema.org data set existed. So the vocabulary for describing data sets existed. It was developed by, that's roughly how it looks. You don't need to understand this, but the idea is it's basically something embedded there that kind of gets showed up as the card like that. Yes. And so when we started using schema.org, the data set existed, but it was mostly used just on data.gov and a couple of other sites. Again, because usually not only the definition of the vocabulary, but also the adoption is really driven by usage. And once sort of any search engine started looking, say, at data sets, a lot more data set, they just started adding the schema.org dataset markup. So basically, Dataset Search, the product that our team builds, is a search engine, and that's kind of the mission that there is. It's that we basically want to help users find where the data is. Importantly, it's a search engine over metadata, as I've already mentioned. We basically search over metadata that we can extract from markup like schema.org, and also that we can infer from the page. Even more important is a search engine over metadata from data providers. That is, it's only as good or as bad as the markup that data providers provide. And that's something sort of both and that's sometimes kind of the pain of my existence, but in some sense, if a particular repository is not in dataset search, it's because they don't have any markup. And we sort of try to sort of oscillate back and forth a little bit on, should we try to extract some of this information? Should we try to guess where something is a data set? But by and large, just as the recipe search, just as job search, we basically rely on the data providers. And that kind of brings me back to the beginning, sort of what I started with, where we talked about the open ecosystem, right? And in some sense, we're sort of determined to kind of be in this context of we want the data providers to actually describe the data sets, not just for us, but for anybody else who wants to build a dataset search engine with kind of lowercase d, lower s, any sort of search engine over data sets, so that but actually create this ecosystem where data providers are sort of feel that they're encouraged, and they feel that there is both the need and it's one both needs to include structured data describing the metadata, but also that there is some use from that. One other thing before I sort of go into kind of how we build dataset search that I want to mention that I think will resonate with a lot of people on this call. I know that from a number of European data portals, it's not the schema.org, but a different vocabulary for describing dataset metadata that's more useful and widely used, which is from W3C, which is the data catalog vocabulary, which we actually, in dataset search itself, actually does understand some of DCAT. I mean, DCAT probably some simplified version of it, but we do. In fact, it's worth noting, and I think it's important, that schema.org description of dataset and its properties is very much inspired by DCAT. DCAT precedes it, and also precedes not schema.org, but schema.org dataset. So and there is a very clear mapping for all the basic properties. So the very clear alignment. Like I said, dataset search does understand DCAT, although we always kind of encourage people to use schema.org, simply because, as I mentioned, there are tons of tools internally that we can rely on, that for understanding kind of schema.org, triples, parsing, and all the good stuff. Because DCAT is the just vocabulary for data sets, whereas schema.org is, again, vocabulary for everything. And you can find, I think there are a few hundred types at this point, and there's a lot of machinery to understand it, to parse it, to map it to knowledge graph, which doesn't actually exist for DCAT. Okay, so I want to spend a few minutes on actually giving you an idea of how dataset search actually works. And then I'll talk, after that, I'll sort of segue a little bit on what we have found recently in analyzing the corpus that we get. All right, so in kind of a very sort of simple way, so what basically we do in dataset search is there is a Google crawl that goes out there, goes through every domain, and then from thousands of domains, millions of data sets, it extracts this metadata, the structured data, in however way it appears on the pages. And then it goes into Dataset Search Engine, where we do several things with it. First of all, we clean it up. And that's probably the majority of the work, is cleaning up the data. And I'll talk about that in a second. But basically reconciling, normalizing, making it something that we can then present to the user. We map it to the knowledge graph. Google, as any other company, has a very large knowledge graph that describes things like people, places, locations, organizations. And schema.org actually has types. So for example, we know that, let's say, a provider of a data set is usually an organization. So we can actually map that value to an entity in knowledge graph. Or that we know that for spatial coverage, for example, we talk about locations. Again, we can map that so that we can provide better search. Finally, another thing that we do is, because data, sort of, we often think about data sets in the sense of scientific discourse. And in fact, our team originated, our internal name is actually Science Search, we originated as a search for scientific data sets. So one of the things we try to do is make data sets first-class citizens in scientific discourse. And that's where Google Scholar comes in, where we're trying to actually find data set mentions in papers so that we can actually say, you know, this data set is cited in this many papers, and kind of give credit to people for publishing data sets. And I'll come back to that point. I think that's something that would be interesting to discuss. So to give you a few more kind of technical details, so what the kinds of things that we do, and we have papers on all of these. But basically, so for example, I mentioned that sort of in the middle here, we do a lot of cleaning. Why do we need to do a lot of cleaning? Because one could ask you, one sort of the initial thought, you know, for most portals, if you think about European data portal, probably most of the fields, you know, are filled out correctly. You know, dates are actually dates, and locations are probably like locations, but that's not how it is on the web. And one thing sort of that we have learned when you're trying to deal with structured data on the web, that anything that can possibly go wrong will go wrong. And anything that you can imagine people miss doing in the way that's not entirely correct, and everything that you cannot imagine that would happen, will happen. So there's several things that we try to deal with. You know, even things like dates. Of course, there's a standard for dates. Of course, we can understand all kinds of other standards, but people put sentences in where the dates should be in multiple languages. So, you know, we're trying to normalize that. There are at least 5, schema.org doesn't help. There are actually some of the things like how to download data or how to specify a download format. There's kind of 5 semi-valid ways to do it. And so we try to, again, normalize it. There's things like there's a lot of duplication, particularly within the same site. So on the one, sometimes it's almost like it is actually too much of a good thing. So if you think of any data portal, and again, ADP is one example, when you search for data set, you get a listing of data sets. It's tempting to actually add metadata to each of them on that search result page, and then on another search result page, but also on the profile page. And so you end up having the same data set described in an exponential number of pages. So we try, again, to deal with that, because, of course, for the user of dataset search, they just want to go to the profile page. But actually, there's nothing in the markup that says this is the profile page. Similarly, and that's something that's particularly important for portals that aggregate information from different sites. Again, EDP is a perfect example of that, is there is the same data set that might be on the French government side, and actually what might be on the city of Paris side, then on the French government, on this federal, on the side for the French government, and then it will be in the European data portal, which is great. And actually that's how ecosystem is supposed to work. But then if you sort of look at it from the other side, from the point of view of, say, dataset search user, I just want one entry, right? I just want this, whatever, some information from the city of Paris. And yes, please do tell me that I can get it from the city of Paris, from gouv.fr and from European data portal, but I want it to be the same. There is vocabulary for that, right? You can actually say it's same as. From everything I just told you in the last 3 minutes, you will not be shocked to hear that same as is not used correctly almost universally. You cannot rely on it. Both when it is used, it's often used incorrectly. We do use it as a signal, as we use a lot of other things, but it's absolutely could not be used to do this kinds of application. These are the kinds of things that we actually have to guess and to learn and to figure out. So we found that that's, we were kind of hoping that at least for government data this would be very reliable signal. It was not. What else do we do? Sort of. Oh, actually, that's what I was just going to say. I forgot I had the slide. So yes, so we do kind of. So we try to kind of find these replicas of data sets on different sites. And again, it's actually a good thing. It's a healthy ecosystem. In fact, it's an important signal if a data set is replicated across multiple sites, right? So we'll look at things like title and description, and there's not a one single way that we for sure know that these two data sets are the same. So we kind of have to use a number of different features and a combination of different features to actually cluster things together. So kind of stepping back, I am a computer scientist, so almost any talk has to have this kind of diagram. So I'll have this diagram, and this kind of describes in general how things work for those of you who are curious. So like I said, there is a crawl. Dataset search does not have its own crawl. That's the beauty of relying on schema.org, because the Google crawl, generic crawl, picks up all the triples. So basically all we get on our side is just a set of triples for all the sites that have schema.org dataset or DCAT dataset. We extract those triples, and then we do all the things I just talked about, reconciling with knowledge graph, normalizing, mapping to Scholar, identifying those clusters. Then we basically index all this enriched metadata, and then we are part of a search company, so things like search and ranking results basically comes from main search. And we largely rely on web search for ranking, in part because, so we're lucky in a sense, which wouldn't, for example, be the case in any enterprise data catalog, that all our pages all our data sets in the index do come from web pages. So there's a lot of web signal to rely on. Again, if you think, for example, of this in the context of an enterprise data search, that's not going to happen because you're not going to have that rich web signal. We actually do have the very rich web signal. And so largely we rely on that. We add a little bit of a signal on the quality of the metadata, on like Scholar citations, but by and large, and it worked. We actually didn't expect it to work. And I think Ellen also has some work with her collaborators on showing that a dataset ranking is different from web ranking. And I completely agree, but actually on a web scale, it ends up being kind of okay. It's not fantastic, and we're actually working on improving it, but by and large, it's actually not that bad. But again, I sort of fully recognize that we're lucky on having all those web signals. All right, so one thing I wanted to talk about, we actually did this work recently. So I've mentioned that when we started this, there was only like a couple of websites essentially that use dataset markup. As dataset search started growing, there were more and more sites. Right now we have, at the time when we did this study, 4,600 different internet domains that have datasets, and that's excluding the tons of domains that we do not include in this count that essentially using the markup as a spam or search engine optimization, or basically have nothing to do with data sets. So, so we did this study where we tried to look at this as a snapshot of data sets on the web and trying to say, okay, so we fully recognize it's not everything. So it's a sort of a selected corpus of everything that has schema.org and DCAT markup. But what can we learn? If we look at these at this set of data sets, essentially, what can we learn about how about data sets in the web? And I think that actually kind of will segue into this discussion of what is the state of open data, in fact, a little bit, and we'll see what I mean. So first of all, as I mentioned, things have been growing quite a bit. So in the last 2 years, we went from like 10 million to more than, actually at this point, more than 30 million data sets. But one interesting thing is, also kind of as everything in the world somehow is guided by power law, right? And it's almost always quadratic, no matter what happens. So if we graph, I mean, as with kind of anything, you know, there are few repositories that are responsible for millions of data sets, and then there's a very, very long tail. In fact, so this is the study mostly from March, so things have changed slightly, but generally 10 domains, 10 internet domains were responsible for 65% of the data sets. So it's a very, very heavy head. However, we're actually focused quite a bit on the tail. Because if you think about it, sort of what I said very early on, kind of the big ones, most people will know what they are, or they will sort of figure out what they are. So those 10 domains, again, if you're not part of that research community, you might not know that DataCite actually has everything. It has tons of data sets. Pretty much any data set with a digital object identifier is in DataCite. If you're not part of the specific research community, you may not know that. But yet, you know, sort of the 35% I think is actually almost more exciting than the 65% that they had. And this is the log plot, of course. And so it's kind of perfectly quadratic for most of it. Another thing that we sort of observed, but it was very interesting for us to get the numbers, is the incredible churn of URLs. And that's kind of, when we talk about persistent identifiers, and that's sort of, I'll come back and I want you to kind of remember this slide, not for the specific numbers, but for the fact of how much things have changed. So if we look at the 14 million data set, we looked at 14 million data sets that we had in June 2019. We looked at twice that number of data sets that we had several months later. The overlap was only about 60%. So because if we just rely on URLs, they keep changing. Data, they come, they go away. The way the data, sort of the way specific repositories structure changes. So there is an enormous amount of churn. There's almost like 5 to 10% churn almost weekly. So only 8.8 million URLs appear in both sets. These are 9 months apart, and these are data sets. This is not just some random page on the web that will be changing all the time. All right. We looked at the types of formats that we have. About 66% of the data sets actually specify the download format in some way, either in schema.org or we're able to extract it from the URL itself, for example, from the file extension. So it's not perfect. And even if it's schema.org says that it's CSV, from everything I told you, you know it's not necessarily CSV. But this is a reasonable approximation. And so about a third of the data sets are actually tabular data. CSV, and similar, Excel, etc. 25% of structured data, things like JSON, things like RDF, things like XML. So there's actually a lot of data there that is in a way that we can analyze and process. The sad part is the 10% that are documents. And these are PDFs. And the number of data sets that are published, mostly PDFs, that are published as PDFs or sort of Microsoft documents is sadly enormous, right? So 10% here is 3 million data sets. And there's a lot of research that's going on trying to extract that information. But that's sort of the sad reality. I remember sort of about 5 years ago, 4 or 5 years ago, someone, Sunlight Foundation actually looked at data.gov, which was at the time really the flagship open government site. And I don't remember the number exactly, but I think it was almost close to a third of the data sets on data.gov were in PDF. And that's kind of a sad commentary on the state of data today. Also, again, sort of thinking about open data, about 38% of the data sets actually specify a download link. The others don't, which is actually not entirely unreasonable because we do include, we don't actually require, I'll talk about, well, actually, I'll get to that in a second about open data versus data you have that is licensed. We also try to classify data sets in different topics. We basically just built a model for that. We didn't try to rely on any keywords because those turned out to be completely unreliable. And you can see that sort of the bulk of the data sets in our corpus are social sciences and geosciences, and then kind of biology and life sciences are next. And the interesting thing about social sciences and geosciences is more the commentary on the ecosystem than anything else. So before we launched the beta version of Dataset Search, we decided we identified a couple of disciplines that we wanted to go after and say, in those disciplines, we want to cover at least, try to cover all the key repositories before we launch. And it were social sciences and geosciences. I mean, it was not entirely random why we chose them. Those geosciences in particular, by then, was building up a pretty healthy culture of publishing data and publishing metadata, but nonetheless, it was actually very interesting for us to see that those two domains still kind of dominate, those two disciplines still dominate the topic distribution in our corpus. This is sort of this cumulative advantage, kind of the first comer advantage that seems to still be there a couple of years later. Now, this is, I think, in terms of sort of the topic for the series of webinars, I think this is the part that's really important, which is, so remember I mentioned a couple of slides ago, this notion of incredible churn in URLs. And again, this is normal. Many of you run or build data portals, things change. You don't want to be beholden to a specific URL scheme that you have designed on your first release, which is where the persistent dereferenceable identifiers come in. DOIs being one of the most sort of pertinent and most well-known examples. And so in the last few years, we have sort of come to expect that for many of the scientific papers, right? There is a DOI and, it will be, and that's how we reference our paper. And again, the key here is both the fact that it's persistent and the fact that it's dereferenceable, right? It can point to a different location if that location changes. What we found is that only about 10% of our data sets in the corpus actually had DOIs, or we also looked at other identifier schemes, but they were kind of tiny slivers there, including identifiers.org. So 10, it actually has grown quite a little bit. It's about 12% now. So that's, again, that's that blue part of the pie would be if we actually making data sets into kind of really first-class citizens of our discourse. That's the part that has to grow, because we have to actually be able to cite and talk to them the way we talk about, for example, scientific publications. Another part of this whole open ecosystem is, of course, licensing and open data. And one of the things that a lot of people don't realize that not having, at least in the US, I don't know how it is in Europe, it might actually be different. Not having a license on your data is actually worse than having the most restricted license, right? Because if I want to use your data, I don't know if I can, if it doesn't tell me that I can use it, I have to assume that I cannot use it. And so here, the situation is actually a little bit better than the situation with DOIs. So we found that about 34% of data sets actually specify a license, which, if I had to guess, I would have guessed a smaller number. So this is actually not so terrible. So about a third, so that's like 10 million data sets that actually tell you what are the, whether or not you can use it. Of those 34%, the vast majority are open. So 82% are free for both commercial and non-commercial use. With different, I'm putting a lot of Creative Commons licenses in here. There could be various attribution and share alike requirements, but basically you can actually use it for free. not available for free, the one that you need to pay for, about 10%. And there are two ways to specify that. One is there are certain licenses that basically don't allow free redistribution. We assume that if the license allows free redistribution, is free because, you know, even if I pay you, but then I can redistribute it, it's basically free. There's also Schemaorg also actually has a Boolean field, whether the data set is available for free. And we actually didn't expect people to use it, but people do use it. And actually they put the not free bit in there, even though we, in fact, if we're actually certain that the metadata indicates that the data is not available for free, we would put a banner saying, you know, data provider said the data is not available for free. And that doesn't seem to deter a lot of companies that actually want to charge for data, which is actually healthy, right? That's how a healthy ecosystem is supposed to work. We all know that data is expensive to produce, and so if a company has actually invested money in creating data so that they think are valuable enough that people will pay for them, we actually index both open, non-open data, but we do try. All we ask is that there is metadata that actually tells users, right, as much as possible about the rights to the data. And so about 10% of the data sets that specify any sort of licensing on access availability requirements do indicate that they're not available for free. And then the small blue in there is free for non-commercial use, but you have to pay for commercial use. And so I think kind of when we think about, in general, open data and the state of open data, to me, kind of this slide kind of summarizes the state where we are. And obviously, we do want DOIs and similar types of identifiers to be much bigger slice of the pie. We want, and again, I won't judge necessarily how much of the data has to be free, but I would like the larger part of the data specify what are the usage rights, and then one can negotiate. It's sort of similar, in some sense, sort of I view dataset search in that sense, very similar to how we used to seeing papers on Google Scholar, right, or Semantic Scholar, or any kind of scholarly search. I find where the paper is published, and then it's basically between me and the publisher to get access to the paper through my institution or by paying the publisher. Sort of, that's the same one. So one thing I kind of want to emphasize now, kind of as I reflect on what I was talking about, is that we actually have a lot of best practices and technical foundations for a healthy open ecosystem. We don't use it all the time, and not every data portal uses it, but we actually have a reasonable set of technical foundations, right? But we need to kind of think about it, and I think we understand better these kinds of what is actually needed for this type of healthy ecosystem. So first, you know, long-term kind of so one of the long-term storage on pages that are callable. So today, I think it's actually not universally kind of accepted, but I think for most of us, we believe that if something is not on the web, it really doesn't exist. So, you know, putting metadata in an XML file that's zipped somewhere that you need to request is really makes that data set invisible. So something that's on the web and crawlable by search engines, at least the metadata. Again, it's very different about getting the data, and that may be, maybe the data is free, but you need to sign a license. That's perfectly fine. But the metadata needs to be accessible sort of on the web in the kind of broader sense of the web. And it needs to be somewhere kind of in a reasonably long-term space. So what I'm thinking about here is, you know, I suspect so there's some people in the call for academics and have the website for their lab, and then they move to a different academic institution, and that website moves. And so the data says that they were publishing on that website isn't exactly long-term storage, and whoever was referring to them, unless there is a persistent identifier, we'll lose that track of where things are published. Again, persistent identifiers, I think, are key, so that persistent and dereferenceable, right? So not only that we can have DOI for a data set, but we can actually point to the location it actually moves. Structured metadata, that's, again, in web-friendly formats. We are in 2020. The web really is where everything lives, that uses standards. ideally sort of standards that are widely understood, but widely interpretable by a large number of players in this world, so Schema.org, and that have provenance information. So I was talking about earlier about sort of that we had to actually go to some length to understand that this data set on a particular city side is the same data set as on the province side. It's the same data set that's on the European data portal. Having that provenance information explicit, correct, and traceable, of course, not only creates a much better experience for users who are searching for data, but actually gives both credit to those who created the data set and gives a very much of an authority signal, right? Like who actually created the data set, if I can trace that provenance. And the licensing, I think, is key. And I think sort of it seems a little mundane, and we're all about data and we want to analyze and we want to do all cool things without data. But if the data doesn't have clear licenses, we won't be able to do much of that. So basically, going back to like just publish data in data repository is not enough. Like all of that. So it's more like dumping data somewhere, but we really want all of those sort of components. And that, of course, brings a lot of both social and technical challenges, as any of these types of things do. And I think actually social challenges are more complex, far more complex than the technical ones, right? And of how can we, what are the incentives for publishing data in a way that's not just, okay, so we can, we can force people to publish data and, okay, fine, I put it on some repository, I provided the minimal metadata, and I checked the box. How can we actually incentivize people to do this in a more reasonable way and and share data in a more useful way? What is the role of publishers and funding agencies here? Technical challenges, we are computer scientists, we want to solve all these interesting technical challenges. I think they're actually in some sense slightly easier to solve than the social challenges, just because we have more control of that, but there are tons of really interesting research questions here, which I'm sure those of you who are working on various types of data portals are addressing things like, and I know you're addressing, like we're all addressing them, figuring out how do we actually do sort of perfect ranking for data sets, how we determine this provenance of how sort of what we know about data sets and how will they go from one repository to another, how do we improve the quality of the metadata, what can we learn from other sources. For example, I don't know, if a data set is related to a paper, can we learn something from that paper, for instance, or from anything else on the web around that data set? How do we find data sets that are similar and related? Can we sort of use what's inside the data sets to actually provide better search, to provide better metadata? And so, and this is not a 21st century issue. As it turns out, data sharing and understanding data sharing is very much been here with us for hundreds of years. And in fact, in 1695, royal astronomer John Flamsteed published some observations about a solar system. And Isaac Newton wasn't happy because John Flamsteed was not providing the data. And in fact, there was a exchange of letters between the two gentlemen, probably sirs actually, that was very exasperated, and they actually really hated each other apparently for the rest of their lives. But one quote that I have here is from Newton to Flamsteed, that these and all your communications will be useless to me unless you can propose some practicable way or other of supplying me with observations. I want not your calculations, but your observations only. 1695. We're in 2020, and I think many of us are just as exasperated sometimes, right? But I think actually the interesting part here is about the practicable way. And I think the practicable way is something that I talked about for the last 40 minutes or so, that way actually it's not just having it there, we need to be able to obtain it and understand it and get it. And sort of, we found actually that quote when we were trying to do an article for Nature Materials. So, these are physicists, so of course we need a Newton quote for physicists. And Nature actually does require its authors to have a data availability statement. And this is Nature. They tell you to write your data by hand, you'll write it by hand if you want to publish in Nature. And so we looked at Nature materials in particular, and it turned out that basically 93% of the papers in 2019, in the first 10 months of 2019, were roughly at the level that Newton has described. They were saying that data was available upon request. And only 7% actually had the data shared. But this is changing, right? So actually Nature Materials has changed its policies now, so has Nature Biotechnology, saying that by default, you cannot say that data is available upon request. Funding agencies in the United States, and I know that European Union as well, are really requiring grantees to publish data in a way that's more practicable, to use Newton's words again, right? It's not just on my website without a DOI so that I can put a URL in my next grant proposal and then the data set disappears. And so all of you have seen this, definable, accessible, interoperable, reusable data. What I talked about today has focused on definable. I'm not suggesting that we have solved that at all, but that's really the part where we have focused, but there's still a lot more to do in making data truly kind of open and shareable. And so the way we think about this is kind of think about this open data ecosystem. I don't think there will be one portal, one search engine, one team that will solve this problem. It really is an ecosystem with a variety of players here, from data providers who publish data in a way that kind of conforms to best practices, consumers who actually cite data. And if you publish data in a way that is citable, we can cite it, we can give credit to the authors, and we can kind of contribute to this larger ecosystem with tools, citations, and data. And with that, I'm ready for questions.
Thank you so much. And we have quite a few questions coming through, so I'll get right to it. Thank you for the presentation. I'm going to start with a question by Franco, who leads on the European Data Portal. So looking in the future and the future of this data discovery ecosystem, Gianfranco asks, do you see the European Data Portal, the national government's portals, and Google Dataset Search to work together, and how?
Yes, for sure. So I'll stop sharing. I don't think you need my screen anymore. Thank you for the question. I think sort of I was kind of trying to end with that. I think it is kind of, it will take everybody. And I think the way, for example, European Data Portal, and we'll work through mostly through Eleanor, but with you guys to actually publish sort of all the search engines will be only as good as the metadata that the data providers provide. Right? The data providers and the data portals still do play the key role here. So I think getting more metadata, publishing more metadata so that we can, for example, give users more information about what they will find when they come to the data, encouraging users to have licenses and, again, persistent identifiers. I think it's where the portals that accept the data, essentially, and they have the data, have quite a large role. And then, yeah, so I think it's kind of, it's a chicken and egg problem, right? So Schemaorg data sets started appearing on the web when we started searching over it. Our search became better when there was more data sets that actually had structured markup, and it kind of continues to build like that.
Okay, thank you for that. So Bob has asked a few questions. I'm going to pick one in the interest of time. He says, communicating about the quality of dataset descriptions to data providers / webmasters could be done by Google via its Google Search Console product, which I'm not familiar with. Is this something that the Google Dataset Search product team is promoting internally towards Google Search Console or externally to data providers? So I guess the question is about how much feedback on the quality and interaction with publishers.
Yes. So I think that is part of the reason. So it's part of the reason why we're also relying on schema.org is because Search Console actually does give feedback to webmaster on any type of, not just data set, but any type of markup that you have. It will tell you if you have errors. So we have worked with the Search Console team. It's not perfect, I think, because dataset pages are sort of the long tail. I think they sample, they don't give you every single data. I know that the counts, and we've tried to work with them to get that sorted out. The counts are not exactly accurate on how many datasets were found on the site. but the errors are usually pretty indicative there. And in fact, because particularly for data portals, I think this is useful because all the pages are generated by code, right? So, if one page has metadata messed up, all the pages probably have it messed up because it's sitting in the database anyway in the first place, and you have some code that generates that page. So even a sample information on the sample is probably informative. But yes, we do work with the Search Console team quite closely to try and, I mean, they added data sets, which was a big deal. I think they added that only in winter. And we try to sort of continue to improve how Search Console reports it back. But again, that's not just for data sets, and that's kind of a nice thing for us. It's for any type of information.
Thank you. Another question. So someone is wondering whether the higher percentage of geospatial data is due to the fact that there are several well-known standards that must be used for the data to be shared between applications. Whether you could comment on that. And the follow-up question is, are there other types of data that are better in the way they are published? So from those categories, did you see some communities being more diligent in the quality of the metadata that they produce?
I think geosciences is certainly a very good example there. And I think geosciences, there were actually a couple of papers, there was in a couple of issues of Nature, there was a comment in an article about how geosciences as a field has essentially turned around in a couple of years. They have done an amazing job. It's not necessarily the number of different other standards, because admittedly, we only understand schema.org, but I think it's easy to translate it in standards. But I think it has more to do with the culture of a specific discipline. And again, I can try to find the links, but Nature, I think in 2019, somewhere in May 2019, had a couple of articles showing that it's really, the field has gone from essentially no data publishing and no metadata to probably being by far one of the best. Life sciences is similar, the bioschemas.org that builds on schema.org, and sort of there's also quite a bit of culture of publishing data. And I think that's where it takes kind of, one of the things that we found, and it's, for lack of a better word, it does take influencers and kind of key people in specific field to start turning things around.
Okay, thank you. Perhaps a slightly controversial question from Axel, who is asking, do we still need data portals at all, or shall we all just publish and mark up the data set? What is the role of portals in the future?
So I don't think it's a controversial question. The answer is emphatically yes. So first of all, someone has to publish the markup somewhere. It should not come to Google by any, we don't want anybody submitting anything to one search engine, be it Google, be it Bing, be it Baidu, be it anything else. That's one thing. So that markup does need to be published somewhere. But more important, by far more important, is that a good data portal for a specific field will always be way better than any generic search engine. There are these there's data set portals in life sciences that present the results of data sets for different parts of DNA, and they will show it to you in different parts of DNA. And geospatial ones will do way better job in exploring data. So the generic search engine or generic portals are good, I think, at bringing people to where the actual data is. But particularly in science, I think there's no way a generic search engine can be as good, or generic search portal, or generic portal for that matter, to be honest, that could be as good as something that's specifically for ocean science or for polar explorer. So there are portals for that. So yeah, the answer is actually emphatically yes.
Thank you. And I'm going to conclude with a question actually from Magnus that maybe Natasha, is a researcher in semantic web community, you'll find interesting as well. The question is actually to Gianfranco, I think, more than you, but I'm going to read it nevertheless. When I look at EDPs or text strings with language tags, when I look at this presentation, we spoke about reconciliation with a knowledge graph. Isn't EDP moving in the wrong direction by not having a knowledge graph? Gianfranco, final words for tonight.
Okay, that's an interesting point, perhaps, or a perspective that is important to share. So the European Commission works on very long-term objectives and needs to move very slowly to bring together the great group of countries and the various level of maturity we are working against. So knowledge graph and the kind of tools that Natasha, lucky here, very envious here, can use and experiment with their team is sometimes outside of our space, or possibly seen as a very wild experiment by our colleagues in the Commission. So we actually know from the plans for the future European Data Portal, there are 6 years of it, that a lot of strange new stuff is going to be experimented. I believe that we are all trying to find our space and what works best. Knowledge graph definitely works nicely the way Natasha described. There will be more to see, but I don't think any of us has the right solution to every problem. Let's try to learn from each other. The same point Isaac Newton made earlier in the quote by Natasha.
Thank you for that, and sorry for putting you on a spot. But it's nice to see that there will be more room for experimentation and ideas and innovation for the European Data Portal as well. Natasha, thank you so much for being here, and thank you everyone for your questions. We didn't manage to pick everything up. We'll share the questions with Natasha after this. There was a few more that I didn't manage to go through. This has been fantastic. Thank you for joining us. We will meet in 2 weeks with another exciting talk from the Google ecosystem as it happens, which will tell you about Kaggle and how they build data communities. Thank you for joining.
Thank you for your questions.
Bye. Bye, Natasha.